Everyone. In this recording, we're going to discuss geospatial data visualization in D3. So the first step is, how do you actually read in data? Remember, we have a few different kind of data formats, but they're more complicated than just CSV, right? So let's focus on vector data. I'll touch briefly on raster data at the very end. But for vector data, what you're almost always going to want to do is convert to GeoJSON. GeoJSON is a special kind of format which can be read in with something called d3.json, right? So here, this is just a path to some GeoJSON object. It's all the glaciers data that we've looked at before. And then from there, you can use it just like you use d3.csv. You give it a .then, and then the function that's going to visualize that object. This is what it looks like inside the visualize function when you've read in that JSON. You have an attribute called CRS. This is giving some geographic metadata. And then you have an attribute called features. And this is just a long array. Each element of this array corresponds to one glacier. And here I've expanded the first glacier, and it shows you all the coordinates. So these are all the coordinates that bound this first glacier. Right. Now, if you just look at it like this in the console, it looks like some basic JavaScript object, right? But it's actually a little bit more subtle. So it's keeping track of all the geographic metadata. And what that means is you can use the d3.geo library to access a whole bunch of features associated with that, each object, right? So in these commands, I've taken each glacier and I've calculated its centroid, right, just the latitude, longitude, center point of each glacier. I've gotten the bounds, so I know the minimum, maximum latitude, minimum, maximum longitude, and the area, right? So these are functions that you would not be able to do on just an ordinary JSON or an ordinary JavaScript object. But since these have geographic properties, you're able to actually extract these sort of spatial calculations. So we can actually just look at it now. Right, so I've just consoled some of the output. Here's that glaciers object which I was just talking about. It's all the coordinates, x, y coordinates. And then here's some of these other attributes. So these are all the centroids, right? So the first glacier, the very 0th glacier, if you looked at the average or the centroid of all these xy coordinates, you would get this pair. Okay. Oops. So that's the d3geo library. It comes in handy whenever you need to do any kind of spatial calculation. Now, once you have the data, how do you actually start visualizing it? Right. We're going to need a way to go from the raw geographic information into an SVG that we can display. Right. Usually we're going to be using an SVG path, and we can use a generator. So the most common kind of generator whenever you work with geospatial data is something called a geopath generator. It's kind of like d3.line, except instead of drawing lines, it's going to help you draw points or polygons or lines associated with geographic objects. And so here I'm showing this is that same glaciers object. I'm able to hover over them. Each of these is actually a path. So let's see how you actually draw it. This is defining that path generator. So G3 geopath. But instead of giving remember we had .x and .y for the line generators, that was mapping the underlying data to the x values of the line and the y values of the line. Here, instead, we're giving it a projection, right? What the projection does is it looks at the underlying data set, and then it maps it to the size of the canvas, right? So it's going to look at the minimum latitude, the maximum latitude, minimum longitude, maximum longitude, and you're going to fit it on a canvas of this width and this height. Since the data technically lie on the surface of a sphere, you need to be able to map it onto just a flat plane. And there are a few different ways of doing that. And D3 has a few different functions that correspond to those different ways. GeoMercator is a reasonable default if you don't have any specific preference. Okay. Now, once we have that path generator, we can just use that path generator as an adder for a bunch of paths that we append to the map. Right. So this is the usual data bind. Notice that I'm binding the features and not just the overall object. The reason is because features is the array where there's one element per glacier. So I've entered one element for each of the glaciers. I've drawn their boundaries using this generator, this geopath generator, and I'm coloring them in according to some property in each glacier. Okay, so that's actually the entire idea. At this point, it's now just like any other JavaScript visualization. We just have a bunch of SVG paths. We can change their adders. We can add a mouse over. That's how I, got this effect, and I have the different names up here. Right? Now, the last point to mention, we've only discussed vector data, and the reason is because visualizing raster data in JavaScript is actually kind of challenging. The reason is there's no native geographic raster support on the browser. Instead, what you usually have to do is you need to take the raster data file and convert it to a bunch of PNG images. And you would use those just ordinary PNG images as the background. It's lost all the geographic metadata. Right? So you can either manually convert it as PNG. There are also some libraries that will convert a really big raster into many smaller tiled PNGs. Right? But it's beyond anything that we're doing in this class. So I've given some links in case you're curious, but we'll never need to use any web visualization for raster data.